Good day, everyone, and welcome to yet another episode of AI Climbing with Sheikh. As we all know, there has been a a lot of hype and talk and controversy on the DeepSeek R1 and what it has done to the open AI and in general to the global AI play. In this session, I will be going through what they have done in general, what is their approach to solving a problem. Look, I do not see that I will need to spend a lot of time explaining the paper and the nitty-gritties because there had been a lot of videos and talk on it. I will be taking more a holistic, a business as well as a technical view together to let you understand that why it really matters today, especially of the fact that the current models consumes lot of power and space and perhaps need lot of computations. And what can be one approach to solve this? I do not believe that it is very optimum or trustworthy, but then it do deliver a sort of value as an SML, especially if you see their lower footprint models like 1.5 billion and 7 billion. So let's try to have a deep dive into this. So, if you are following the industry, I believe you must have known about the two famous papers they have released. And I will be covering a very light touch on both of these at the end. But first of all, let me try to explain about the architecture principles and their approaches and what makes it differentiate from the other models. One of the key questions which everyone asked recently, like why DeepSeek can deliver the value, both performance and cost at a lower scale. If you see some of their announcements, they told that they can build the LLM with 2000 GPUs training compared to the 100K, which is needed by the OpenAI. And then naturally, it means you can reduce the cost from 100 million bucks to perhaps a 5 million, 5.5 million. So how they have actually approached is more like the approach of agentic AI and from the top. If you can see that what they have done really reduce the matrix calculations from dot 32 to dot 8. What it actually means that in a typical combination and matrices and vector calculations, what typically OpenAI do is do store the numbers with 32 decimal places. But now, what DeepSeek has done, reduce it to dot 8 places. What actually it means is it needs less space for the same work, but then naturally it impacts its accuracy. But this problem they have solved by introducing a concept which is I call a more like a domain delusion, because you really need to see for an AI to understand a thing clearly, it needs to not only store the strong combinations, right? For example, a cat runs or cat eat a cake. So if you see the cat and the cake has a very close relation, but then whether it run or sleeps has also a weak relation, and you can't drop this relation. And what they have done, they have put a wrapper a logic around it, which is more like a domain delusion, like that still with lower calculations, it can result in a high accuracy for a domain specific task. It means that in terms of math, lead code, and specific tasks, actually they can perform quite well. And I will be touching a bit on how they do this. And The other key capability is distillation, and you need to see what the distillation actually means. That you start with a very big model. They have the DeepSeek base model, which is 671 billion parameters. And ultimately, it's not just limited to that. I have tried, and you can use Olama as well. You can also use OpenAI based model. The whole idea is this, that this model starts at a lower scale, and then for the task you do not know, it asks the teacher model, something like what Instruct Labs and the lab architecture does as well. But then the important thing is the teacher model do not gives us the answer, but also the logic, the calculations which it store, which means over time its training and logic increase exponentially, which I will be talking a bit as well. The four, which is bold and a bigger size, is the reinforced learning. And the best example of reinforced learning is teaching and training a dog with the bone. And you really need to see that you give dog a bone for a good task and takes its bone for a task which is not very encouraging, and over time the dog learns, and that is what they have done to deliver a better accuracy with the lower computations. The last piece, an important piece on the performance, is the off policy means. It actually means that you calculate new trajectories, not based on the big of n or all the combinations, but actually from the subset of the trajectories which you prioritize over time. What it actually means that you do not need to do lot of computations, but actually just subset of it which is driven by a algorithm. And then you need to see that how further it enhances the performance. So they use an algorithm which they called GRPO, which is Group Relative Policy Optimization. And the whole idea is that on the group level, accumulative level, as well as individual level, you give better weights to actions with good rewards. It is really important because it gives you both an accumulative view, not just you make a decision for the current action, but also see the impact of the long term reactions or the reward coming out of it. Then a rule-based reward, again, a typical ML algorithms use PPO. So unlike the PPO where the rule is done by annotations or label data, here the you calculate the rule based on a logic and bound it on the upper side as well. Reducing variance, again, without checking every possible combination, you will reduce the variance and improve the accuracy. And how you normally do it, you actually do it without calculating every possible combinations, but actually rely on just few samples of it. And what it leads to a infinite context building, right? Overall you will see that the model will perform better and it will grow in its intelligence infinitely theoretically. Again, natural constraints of compute power and how your data sets are mapped matters, but that is really the key principle here. If I now try to take a view of a lessons learned, so look, first of all, we really understand that what is coming next for the industry is more like a teacher-student model type of architectures, which gives better performance and scale and context for your industry. And then one of the key thing I was observing about the sourcing of data, because the DeepSeek did not explain it well. Apparently, it looks that they got the curated data from someone like OpenAI or whomsoever. But naturally, it is clear that they did not pre-process, processed, or mapped the data, which raises a lot of questions around the trust, regulations, because you really need to see, right? AI can do marvel, but then if the data pipelines are not mature and stable enough, then whatever you get, it's just garbage out. I hope you get the point. And now, coming from the more logical and the business view of the overall world, I really want to take you to the paper a bit and how they do it. So, one thing you really need to understand is the concept of reinforcement learning through group relative optimization. You can see this more like an algorithmic or the pie view of the world. By the way, all the policies and the computations are calculation are reflected through a pi functions where theta is the subject or the objective function which you are going to optimize over time. And if I really want to say, it is calculating a reward mechanism, which you can actually see over here. This is the reward. There is an upper bound which they are showing through the clip function. And then if you can see over here, if you follow reward, ultimately it will grow infinitely. So they are upper bounding so that reward do not becomes just the only one criteria. In other words, you really need to bring a more realistic view of how humans normally think and apply it to the machines. There are some good results which you can see over here. They are very good in terms of accuracy, and I hope I try to explain that why accuracy is a good direction for them, but perhaps not for you. As an example, if you do a more like a human intelligence view, you need to calculate different other metrics. One such is RAGU or recall oriented understanding of guessing evaluation and few other models. But that's pretty much important that recall, precision, lot of other parameters, cross entropy also you should view. And the last piece I really want to see this, I really loved this slide because if it really gives you a view how the context window will grow over time. So you know you can start actually with zero, but then or maybe few context window, but then over time it really grows exponentially, which means it can gives you a more candid and knowledgeful and human-like view of the thing. You can see about the more details, but almost everything I have actually covered: hot start, cold start, and how they apply the upper bound function. What perhaps I really want you guys to have a look is the deep seek this technical report. I will put a link into the comments, but if you see over here, the whole idea is this: it will do a more fine grained quantization, which actually means that both as you convert your text into tokens and apply the limits, it can really do this quantization at a better level, which enables us to know what are my priority tokens and apply the dotted decimal computations onto it, and then over time increase the accumulation precision onto it. Again, I highly encouraged to have a view onto this, but then I have tried to cover this in the most simple way. And what I have tried to do in this paper, not focus just on a technical scientist view, but trying to understand that market is big. Naturally, there is a problem LLM solves. Then there is a problem which you need to see from the data side. But then there is a place for SMLs. And for me, this is where DeepSeek truly fits in. And the time will tell whether there is a hybrid model possible. But look, that naturally is the evolution part of the industry. If you like this video, don't forget to subscribe to the channel, and let's try to keep on learning for a better AI success overall. Thank you very much.